Hi everyone, in this video we are going to talk about how to graph an absolute value function as a piecewise function. So one example would be to graph the following function, f of x equal to the absolute value of x squared minus 2x minus 8. So what are some general steps when we encounter such a question? So step 1, think about f of x equal to x squared minus 2x minus 8, which is the part inside the absolute value sign. What would be a brief sketch of this function? So based on our knowledge about a quadratic function, the general formula is y equal to ax squared plus bx plus c. But first we know that this negative 8 would be the y-intercept. So negative 8 is right here. And also, we want to know the two x-intercepts or the roots of this quadratic formula. The way to do so is to set this x squared minus 2x minus 8 equal to 0. Then we factor, and we will get something like x plus 2 times x minus 4 equal to 0. So based on the zero products law, we have x equal to negative 2 or 4. So these are the two roots of this function. And in the graph, it can be indicated by the x-intercepts. So our graph, and also a in this case is 1, which is positive, so the graph will face up, will opens up. So the graph will look like something like this. After sketching this brief sketch, our second step would be to think about f of x equal to absolute value of x squared minus 2x minus 8 as a reflection of all the parts that are originally below the x-axis over the x-axis. So what would be a brief sketch of the new graph of this absolute value function? So as we saw before, our graph for the original graph would be something like this one is negative 2, this is 4, and this is negative 8. So we want to reflect all the negative parts, which are the parts that are below the x-axis, up to be above the x-axis. So let's take a look at this part right here. So these are all extended infinitely. So do we need to reflect this part? The answer is no, because they're already above the x-axis. Do we need to reflect this part? The answer is yes, because they are currently below x-axis, so you want to reflect them up. What about this part? Do we need to reflect it? The answer is no, because it is also currently already above x-axis. So if we take a look at it, the new graph will be the graph that's in the blue highlighter. So after this step, we will have something like this, which is a brief sketch of the absolute value function. But this is not the piecewise function yet. So our third step will be to write the absolute value function as a piecewise function based on the corresponding domain of each part of the new graph. The most demanding process of this question is to find the corresponding domain. So how can we do that? So first, we will not worry about the original graph anymore. We just need to deal with the new graph, which is the a graph for the absolute value. And we have the two x-intercepts at negative 2 and 4. So we can see that if we take a look at this thing, this part and this part, these two parts are actually identical to the original graph of the function without the absolute value. So we can see that these two parts are actually identical to the graph of f of x equal to x squared minus 2x minus 8, because these two parts not only exist in the graph of the newly drawn absolute value function, but also in the original quadratic function. But what about the reflected part? If we reflect it, what would be this function be? So we know that if we reflect a function, we just put a negative sign in front of the whole thing. So this would be the graph of the reflected part, which would be negative x squared plus 2x plus 8. So we can see that this absolute value functions graph actually consists of two different parts of functions. So we can write them out. So fx equal to x squared minus 2x minus 8, which is actually the two red parts right here. And fx also has a possibility to be equal to negative x squared plus 2x plus 8, which is the reflected part. And now, after this step, we will see that for each of these distinct parts, they actually have a specific domain attributed to them. So, we can see that for x squared minus 2x minus 8, which is actually the red part, only for x less than or equal to negative 2 or x is greater than or equal to 4, the graph would be x squared minus 2x minus 8. And similarly, for x is greater than negative 2 or less than 4, this domain, which is this part, the graph will be the reflected part, the upside down quadratic. And just be careful that we want to put this equal sign to the domain of the original graph, or the graph that is inside the absolute value bracket. So I think up until this point, we would have a piecewise function for the original function of f of x equal to the absolute value of x squared minus 2x minus 8. I think that's all for how to solve for a piecewise function. How do you graph from an absolute value function to a piecewise function? Thank you very much for watching and have a good day.